Welcome to this explainer. We're diving straight into a totally fascinating medical mystery today, and it's all about the neuroscience of leaving your physical body on command. For centuries, right, stories of out-of-body experiences have felt like, well, something straight out of science fiction or mysticism. But what if the ability to literally float outside of your physical form wasn't magic at all? What if it's just an untapped, hidden quirk of human neurobiology? Today, we're unpacking a really groundbreaking single-case fMRI study that looks at exactly what happens inside the brain when someone willfully triggers a somatic, out-of-body sensation. Let's get into it. Imagine just lying back, closing your eyes, and suddenly, you're floating above your physical self. I mean, most of us can't even fathom what that feels like, but today, we're looking at a perfectly healthy 24-year-old psychology grad student who claims she can do exactly this, entirely at will. The crazy part? She just stayed after class one day to casually mention this ability to her professor, genuinely surprised to learn that not everyone else could do it. To her, it was just, a totally normal part of life. Her own words brilliantly illustrate just how visceral this experience truly is for her. She told researchers, "I am the one moving. Me, my body. For example, if I spin for long enough, I get dizzy." She actually discovered this ability during preschool nap time. Bored and looking for a distraction while the other kids were sleeping, she realized she could just sort of pop out of her body and float. She described a very real, dizzying, kinesthetic sensation, sometimes bobbing like she was on ocean waves or spinning horizontally. Moving into Section 1, Illusions and the Brain, how we map our physical selves. So to even begin to understand her incredible ability, we really have to look at how flexible our brain's map of our body actually is. A classic example of this is the famous rubber hand illusion. Maybe you've seen this. You hide a person's real hand, put a fake rubber hand in front of them, and then stroke both of them simultaneously. Almost immediately, the brain's sense of body ownership gets completely manipulated. The person literally starts to feel like the fake rubber hand is part of their own body. It proves that the brain can absolutely be tricked into shifting its perception of where our physical self actually resides. Now, the crucial point here is how our participant is totally different from the typical clinical literature. Usually, out-of-body experiences are involuntary. They're these intense, sometimes really scary hallucinations linked to brain lesions, epilepsy, major psychiatric syndromes, or dissociative drugs like ketamine. Basically, they're anomalies. But this case study? Totally different. The researchers termed what she does an extra-corporeal experience, or ECE, and incredibly, she's a perfectly healthy person, experiencing zero emotional distress, who can literally start and stop this profound sensation entirely on demand. All right, Section 2, inside the fMRI scanner, testing the impossible. So how do you actually test a claim like this? Well, the researchers put her inside an fMRI scanner, using a super clever set of control tasks. They asked her to alternate in a block design. In one run, she'd perform her extracorporeal experience, like bobbing or spinning above her body. In another run, as a control, they simply asked her to imagine herself doing jumping jacks. And then in a third run, they had her perform actual physical finger movements, and then imagine those same finger movements. This gave the team a perfect baseline to compare her ECE against. Next up, Section 3, the brain map revealed. What lights up and what goes dark. When they analyzed the data, the results completely blew away their expectations. When looking at the bright activation areas on the left side of her brain scans, you'll see something amazing. During her extracorporeal experience, her brain's motor centers, specifically the supplementary motor area and the cerebellum, which, are heavily involved in coordinating physical movement, well, they lit up like fireworks. This intense cerebellar activity actually perfectly explains why she genuinely felt dizzy when spinning in her mind. Her brain's movement centers were firing as if the physical rotation was actually happening to her body. And crucially, this activation perfectly overlapped with the temporal parietal junction, or TPJ. Now, the TPJ is this highly multimodal brain area where all of our senses converge. Neuroscientists have long suspected the TPJ to be the true seat of corporeal awareness. In fact, in patients with epilepsy who experience involuntary out-of-body sensations, it's often the TPJ that's misfiring. So the fact that her voluntary ECE strongly activated this exact same region, that validates she is genuinely tapping into the brain's core mechanism for bodily self-consciousness. But check out this stark, super fascinating contrast. While her motor centers fired up, her visual cortex, specifically areas like the lingual gyrus and cuneus, completely shut down. We're talking a dramatic reduction in activity compared to a resting state. And this is absolutely vital because it proves she wasn't just having a visual hallucination. She wasn't simply playing a movie in her head of herself floating, her brain was actively inhibiting its visual processing centers. This beautifully clarifies the difference between what we call visual imagery and kinesthetic imagery. Visual imagery relies on the visual cortex to actually see an action from afar, like watching a screen. But kinesthetic imagery relies on motor areas to physically feel the sensation of movement from within. So this proves that her extracorporeal experience is a highly unusual, incredibly intense form of kinesthetic imagery. She isn't picturing the movement at all. Her brain is physically feeling the movement of floating outside her body. Mind-blowing, right? On top of that, researchers noticed really high activity in the middle and superior orbital frontal gyri. Think of these as the brain's internal GPS and action monitoring regions. They provide feedback based on what we're physically doing. The fact that these regions were so highly active means her brain was monitoring her floating and spinning sensations almost as if they were real physical actions that required constant tracking and adjustment in physical space. Now, you might be asking yourself, hey, isn't this just what happens when anyone vividly imagines something? Well, no. When we compare her ECE to her just imagining doing jumping jacks, the brain pattern was entirely different. Her jumping jack imagery was much more bilateral, meaning it lit up both sides of the brain equally, and it totally lacked that intense, profound visual shutdown we saw earlier. This proves without a shadow of a doubt that her out-of-body state is an entirely distinct neurofunctional phenomenon, completely separate from just imagining a normal physical exercise. They also ran that final control we mentioned, comparing her actual physical finger movements against imagined finger movements. The data here further validated that her brain cleanly distinguishes between standard motor tasks, standard motor imagery, and her unique out-of-body ability. The EEC isn't just some extension of normal imagination, It's a specific, localized brain network involving the temporal parietal junction that she has somehow learned to toggle on and off like a light switch. Moving to our final section, Section 4, Rewriting the Neuroscience of Self. Are we all capable of this? So what does this single fascinating case study actually mean for our understanding of human brain plasticity? Well, first off, this is the very first documented non-pathological, voluntary extracorporeal experience. It essentially proves that a healthy brain can selectively alter its own spatial coordinates. But perhaps the most exciting theory the researchers propose is that this might not be an anomaly at all. They boldly hypothesize that, much like synesthesia, where people taste words or hear colors, this might actually be a widespread childhood ability. But because society doesn't exactly encourage us to practice floating out of our bodies during nap time, the rest of us simply lose those neural pathways as we grow up. She just happened to keep practicing it. Thank you for joining me on this explainer. It really leaves us with one deeply provocative question to ponder. Is it possible that your brain still has the hidden power to step outside itself, if only you knew how to trigger it? Perhaps the boundaries of our physical selves are much more like suggestions, just waiting for us to figure out how to bend them.